So section 1.4, we talked about linear equations. So we're going to change our focus in this section. We're going to be looking at quadratic equations. Quadratic equations have a basic form or a standard form as well. And its form is ax squared plus bx plus c equals 0. You'll notice that that's a little different than the last one. First of all, you don't see a y equals in this, right? That's not what we're working with right now on this. You also see that the right-hand side actually has it equal to 0. None of our linear equations had that feature to them. So what we're going to look at in the first part of this section is some factoring, and we've talked about some factoring techniques. We've talked about the AC method. We have talked about trial and error, and many of you have expressed that you've seen or used slide and divide before, though I'm not going to teach you that one because I think it hides things a little bit too much for me to feel like it's very obvious what's happening. But that's what we're going to be using, is one of those three methods you're going to be using, and you're going to be using it to factor. Now, what we did in Chapter P is we didn't have the equal 0 part. We had what was on the left of this thing, and we factored it into its polynomial pieces, but we stopped there because we didn't have an equation. Well, now we actually have an equation, so we go one step further. So as we're looking at this, if you'll remember, I mentioned back at that point that trial and error tends to work very well when I have a coefficient of 1 in front of x squared. So my default with you guys is going to be that when I see that coefficient of 1 in front of x squared, we're going to try to do it with trial and error. And if we see a coefficient that's not a 1, then I'll do it with the AC method. But you can use either one for either type. It's totally your choice. So on the trial and error, because I have x squared at the beginning with a coefficient of 1, they become x and x. And that's why this process tends to work pretty well. This one's actually really nice. Because, well, it's not necessarily really nice, but it's nice that the 8 at the end doesn't have a ton of factors. There's not a lot of things that I could choose, right? I mean, 1 and 8, 2 and 4. That's pretty nice. I mean, it doesn't get a whole lot cleaner than that unless the number at the end had been prime. So I don't have a ton of things to try. The thing that's not nice about it is that I do have a negative sign, which means my signs don't match. And that sometimes makes things a little bit more challenging to think about because I have to actually do subtraction instead of addition when I'm doing the comparisons. So I need two numbers that multiply but to 8. I already mentioned that's either 1 and 8 or 2 and 4. Right? Those are the only options. And I need to place them in such a way that when I do the inner term and I do the outer term, I end up getting a positive 2. So do we want 1 and 8 or do we want 2 and 4? We want 2 and 4, okay? We do want 2 and 4. And when we want the 2 and 4, we want the 4 to be bigger because I need it to be 4 minus 2, not 2 minus 4. So I need the 4 to be the positive and the 2 to be the negative. So in fact, I get 4x here, negative 2x here, and that adds to positive 2x. Okay, so whether you're showing that on your paper, the swooping like things underneath, or whether you're just thinking about it, that's what you're looking for. So we can now set each one of them equal to 0. So this is where we would have stopped before because we wouldn't have had the equal 0. That didn't exist when we did section P, right? Chapter P. We didn't have that part. We do now. So what that means is that in order for these two things being multiplied to equal 0, one of them has to equal 0 already. Either x plus 4 equals 0 or x minus 2 equals 0. One of them has to equal 0. And then we actually have linear equations that we can solve much like in the section we just completed. So x is equal to negative 4. Or if I add a 2, x is equal to 2. You're welcome to simply write one statement that just says x equals negative 4, 2, like that. Like it's just a list of numbers. That's fine. It doesn't matter to me. You don't have to, but you might see that written like that in the back of the book, I think. But these are our two possible solutions, and there are two of them for our equation that we started with. So factoring is one way to solve a quadratic equation. But what we're going to do next is we're going to look at some of the other ways to solve a quadratic equation. Because sometimes factoring either doesn't work, it's just not possible, or it's simply not convenient based on the way that the problem is given to you. Okay? So the square root principle is actually a really nice method for solving when it has, again, a certain form. So in particular, what you see on part A here is you don't see a linear term. We've got the squared term, we've got the constant term, but we don't have that in-between term with just the x next to it. So the square root principle has that kind of a feel to it. So when we have that ability, like we do here, we're going to add the 8 to the other side. So my x squared is now equal to 8. And how would I solve an equation like this if I'm trying to find x? We would take a square root. Now, when we take a square root, we introduce a positive or a negative. So anytime you insert a square root into a problem where there wasn't a square root originally, you put a plus or a minus on it. And we have to simplify the square root 8 part as well. So 8 simplifies into 2 times 2 times 2. And 2 of my 2's can come out. 1 of my 2's stays where it is. And I end up with this solution. X is plus or minus 2 square root 2. Okay? B looks a little bit different, but it has the same type of property. I have something being squared is equal to a constant. Okay? So while it may be possible to like square this all out, multiply everything, get it on the same side and factor, that's definitely not the quickest approach on this particular problem. Because it's already nice compactly like factored for you as something squared. So I'm going to do much like I did on the previous problem. I'm going to take the square root of both sides. So that gives me x minus 3 on the left. And because we put the square root on, we put on a plus or minus. Now the negative underneath the square root means that I can pull the negative out as an I. So I have an I. And then if I'm factoring 20, it factors into 2 times 2 times 5, or 4 times 5, right? I duplicate my 2's, so much like on the last problem, a 2 will also come out with my I. So it's 2I, and the 5 stays underneath. Okay? So I hope that as we are working with these, you're seeing the usefulness of the things that we tried to connect with back in section P, because they're coming back up very quickly. I want x alone, so my last step then is to add the 3. The 3 doesn't combine with anything because it's not a like term. Typically, we see the 3 written before the plus or minus. It doesn't have to be. That's usually where it will be written, so that our solution looks something like this. So that's the square root principle. All right, so what we're about to shift to is probably not going to be your favorite method. Just going to throw that out there right there. It's probably not, but it actually has usefulness in about 3 different places that we're going to encounter it. We encountered it once already. We encountered it when we talked about circles. When we found the standard forms of circles back in section, was it 1.2? No, it would have been 1.3, the one you just did. When we were finding like the center and the radius and such of circles, we did completing the square. So that was our first exposure to completing the square. This will be our second exposure to completing the square, and we will have one more later on, and I think it's chapter 3. So completing the square is one additional way to solve a quadratic equation. So what we're going to do is we're going to keep the pieces that have the m's in them on the left, and we're going to move any constant to the right. But we're going to leave like a space between. So right now this is what I have. I have m squared minus 12m space equals negative 33. Now we talked back when we did circles that the key to completing the square is to take the b value, divide by 2 and square it, right? So this feels just like what we did with circles. We take, in this case, the value that's next to the m. That's my b value, right, the number that's the linear. We divide it by 2, so I take the negative 12. I divide it by 2 and I square it. So what's negative 12 divided by 2? 6 or negative 6, really, and then squared I get 36. So this is 36. And in that blank spot that I left, I put a 36. But as with anything with equations, if I add something to the left, I have to add it to the right to balance. So I will also add the 36 to the right. Okay? Just like when we found the centers of circles. Identical. So why? Why is that useful? Well, because what it creates over here, if you remember, is this beautiful way of it factoring. That's what completing the square does. Completing the square gets this bad rap, but it's actually really nice because it creates factoring that's super simple. So over on the left-hand side, if you'll remember, the way that the factoring works is that this piece, you take the square root. This piece, you take the square root. So I have m at the beginning and I have 6 at the end. And then use the sign of what's in the middle, and it's squared. And it always works that way. Even if there's fractions involved, it works always. On the right-hand side, what is negative 33 plus 36? 3. So, why? Well, because now I can use the square root principle. Right? I've got something compacted and squared on the left. I've got another number on the right. It looks just like the second one here, B, started out looking. So, I can take a square root. I am left then with the m minus 6 on the right. On the left. On the right, since we put the square root on, we have to put a plus or a minus. But 3 doesn't simplify, so it's just square root of 3. And then I shift the 6 to the right. And again, it's typically written in front, so we have a 6 in front, plus or minus the square root of 3. If you had attempted to factor this question, it would not have worked. This will not factor. And probably if you looked at it pretty quickly, you'd find that out. 33 doesn't have a lot of options. It's either 1 and 33 or it's 3 and 11. And neither one are going to give me the middle to be negative 12. I don't get that quick, so it doesn't work. So completing the square is one viable option for solving this. I think I have one more of completing the square. Well, that's weird. A double slide. Okay. So this one is in the completing the square section, so that's how we're going to do it. It may factor, but that's not what our goal is in this problem. I want to present this one to you because it's a little weird, and the reason it's a little bit weird is because of that 3 in front of the x squared. Right over here, m squared, I know this isn't my slide I worked things out on, but my m squared had a coefficient of 1. And this one has a coefficient of 3. Completing the square only works if the coefficient at the beginning is a 1. So the first thing that we actually have to do here, which doesn't make the whole process very pleasant, is we have to eliminate it by dividing by 3 on everything. And we automatically get fractions involved, which makes things look ugly. So we're going to divide by 3 on each term. So now I have x squared. I have 1/3 x. I'm going to leave a space, and it equals 2/3. The reason I have this example in here is because I want to show you the benefit that completing the square gives you in terms of how nice things factor. So we had mentioned on the previous slide, and we've mentioned it before, that the key is to take b divided by 2 and square it. The unfortunate part is that my b value here is the number 1/3. It's not super, awesome. It doesn't evenly divide by 2. But we can do it. What's 1/3 divided by 2? 1/6. And what's 1/6 squared? 1/36. Okay? So we're going to add 1/36 to each side. Okay, so I know I still don't have buy-in from anybody because I've got my worst fractions going on, right? This is worse than it was before. But there's some nice things that are going to happen. And in particular, the reason I want to mention it is because the factoring on the left is very nice. It's nice because you don't have to work very hard for it. You take the square root here of the x squared, that's x. You take the square root of the 136th, that was 1/6, and you take the sign of what was in the middle, that was positive. So you don't have to work for the factoring on the left. It's already, all the work's been done. Now on the right-hand side, you do have to get a common denominator in order to add these together. So I do need to multiply this by 12. So I have 2 times 12 is 24. 24 plus 1 is 25. So 25 over 36 is what I have on the right. So watch this. We will now take a square root. Of course, on the left, I just get x plus 1/6. I put the square root on, so I need a plus or a minus, but this square root is actually a perfect square root. Because what's the square root of 25? And what's the square root of 36? So this is actually just the fraction 5/6. Now, that seems like it's really good. I think that we all tend to look at this and say that it looks kind of ugly over here, that my answer has a radical in it. But actually, by the fact that it actually simplified, right, the square root actually simplified out of it, it means I have more work to do on this problem than I did on previous problems. Because it means that when I add or subtract, in this case, subtract my 1/6 to the other side, it actually can be combined with what's over there. I don't just get to write it in front and call it good, like I did on the last ones. So I actually have two equations. I have x plus 1/6 equals 5/6, and I have x plus 1/6 equals negative 5/6, and I have to do them separately. So when I do the subtraction of the 1/6 here, 5/6 minus 1/6 is 4/6, and 4/6 simplifies to 2/3. So that's one of my answers. Here, when I subtract my 1/6, negative 5/6 minus 1/6 is, negative 6/6, which is negative 1. Sorry, my negative's missing. Let's try that. So my two solutions are actually 2/3 and negative 1. So let me tell you a true fact that's going to make you feel utterly defeated, but just for the moment. If the answer works out like this at the end of the problem, where there's no square roots involved, it meant that the original one that I started with was actually factorable. So 3x squared plus x equals 2. I would have been able to move the 2 to the left-hand side and factor it and solve it lots easier. Okay, that's really what it means. Sometimes you have flexibility. You get to choose how to solve the problems. Sometimes you're told how to solve them. All right, so that doesn't really help you in the sense of like, well, shoot, I could have done it a different way. Well, no, you couldn't have if the directions said to do it with completing the square. You still had to do it that way. But it does mean, and all of these actually have the ability that once you get to the end of the problem, x equals, if you wanted to make sure that they were right, like it's an even one in the book that's not even in the back, right? You could take 2/3 and you could plug it in for the x's here, and it should be able to be simplified on the right-hand, I said it right first, on the left-hand side to equal what's on the left-hand side too. The same thing for the number negative 1. They should both be able to plug back into the equation and solve it. Okay, we're going to stop right there because what's left in this section is actually the quadratic formula. And all of that goes together really nicely, and we will have time to do that along with 1.6 next class period, because 1.6 is not truly dreadfully long either. So homework from 1.4, table 1.5 for now, and we will complete it next time along with 1.6 and a quiz. So make sure that you're preparing and thinking about the quiz as well.